observed that we can define sine inverse x where the domain of sine inverse x, that is the value of x, it can take between a closed interval -1 to 1 and the range, that is the value of sine inverse x, have to be confined between -π/2 to π/2 closed interval, and to that we call range. So now similarly we can note down and we can justify ourselves the domain and range of all the inverse functions, sine inverse, cos inverse, tan inverse and so on. Let me note it down. Principal value branch, principal value branches of inverse trigonometric functions along with their domain and range. So just note down this table where against every inverse function we are noting down the domain and range. So here I write sine inverse x, domain and range. What is the domain of sine inverse x? That is x lies between closed interval -1 to 1. And what is the range? That is the value of sine inverse x, or theta lies between -π/2 to π/2. Here I have written purposely that what do you mean by range? That is the value of sine inverse x or theta may lie between -π/2 to π/2. What I am calling range here is actually the principal value branch. Then for cos inverse x, the domain remains the same, and but range, the range of cos inverse x is the closed interval 0 to pi. And for tan inverse x, the domain is set of real numbers. That means x may be any real number, but the range is the open interval -π/2 to π/2. Now next, cot inverse x, again like tan inverse x, its domain is set of real numbers and range is the open interval 0 to pi. Next, for sec inverse x, the domain is set of real numbers except lying between -1 to 1 open interval. So it is r minus open interval -1 to 1, because x cannot take value between -1 to 1, and the range is the closed interval 0 to pi but except π/2, because you know cos π/2 is 0, so sec π/2 will not exist. So sec inverse x cannot assume the value π/2. Now finally, for cosec inverse x, again the domain is the set of real numbers except lying between open interval, lying in open interval -1 to 1, and the range is the closed interval -π/2 to π/2, -π/2 to π/2 except 0. You know, sine 0, 0, so cosec 0 will not exist, and hence the value of cosec inverse x can never be 0. So this is about, we have noted down the domain, that is the value of x to be replaced, possible value of x, and the range which the value of inverse function can assume. And now let us take few examples that how to find the value of the different inverse functions for numerical values. But before I take that, let's see, look at this table. The coordinates, 4 quadrant if I call 0, π/2, pi, 3 π/2 and 2. Please note that all the inverse functions, the value of all the inverse functions will lie in the first quadrant provided x is greater than 0. If x is positive, provided x is positive. You can check that the first quadrant is common in all the in all the principal value branches. By that I mean whether sine inverse x, cos inverse x, and so on. And when will it happen? When x is a positive number. When x is positive. But what if x is negative? If x is negative, for example, if x is equal to negative k, x is equal to negative k, where k is a positive real number. In that case, the value of cos inverse negative k and cot inverse negative k and sec inverse negative k will lie in the second quadrant. This will lie in the second quadrant. But for sine inverse negative k, cot inverse, sine inverse, I'm sorry, not cot inverse, tan inverse negative k and cosec inverse negative k will lie in the fourth quadrant. I repeat all this and will justify with the help of example that when we are finding the value of an inverse function, say sine inverse x, and x is positive, whether sine inverse, cos inverse, tan inverse, any, all the six. If x is positive, the value of the inverse function will lie in the first quadrant. But if value is negative, the number x is negative, then in case of sine inverse, tan inverse and cosec inverse, the value, the angle or the value of inverse function will lie in the fourth quadrant. But in case of cos inverse, sec inverse and cot inverse, it will lie in the second quadrant. Let me take an example for each one of them. Let's take an example. Find the value of the following. Find the value of the following. Value, of course, the principal value. Say sine inverse root 3 by 2, cos inverse 1 by root 2, tan inverse 1 by root 3. Here I have chosen all the three values of x positive. Sine inverse root 3 by 2 means what? What is that angle whose sine is root 3 by 2 positive? And you know the principal value branch is negative pi by 2 to pi by 2. Sine is positive in the first and second, but in the principal value branch we can take only in the first quadrant. So it is 60 degree. You know sine 60 is root 3 by 2 or pi by 3. So sine inverse root 3 by 2 is pi by 3 and not in the second quadrant. Similarly, cos inverse 1 by root 2. Now what is the principal value branch for cos inverse x? It is principal value branch for cos is 0 to pi, and cos is positive in the first quadrant, but in second it is negative. So we will take only in the first quadrant. What is that angle whose cos is 1 by root 2? Pi by 4, 45 degree. So it is pi by 4 again in the first quadrant. Now for tan inverse 1 by root 3. You know what is the principal value branch of tan inverse x? It is negative pi by 2 to pi by 2 except the boundary point negative pi by 2 and pi by 2. So again it is positive in the first quadrant. What is that angle whose tan is 1 by root 3? 30 degree or pi by 6. So it will be pi by 6. So when I choose tan sine inverse x, cos inverse x, tan inverse x and similarly the other, where the value of x is positive, then the respective value of inverse functions will lie in the first quadrant. But what if these are negative? Let me take example 2. Say what is the value of sine inverse negative half? First part. Or what is the value of cos inverse, say, negative root 3 by 2? Or tan inverse 1 by negative 1 by root 2. Negative 1 by root 2. Let me take one by one. For the first part it is sine inverse negative half. You know the principal value branch is negative pi by 2 to pi by 2. Yeah. And sine is negative. Let this be an angle theta. So that means sine theta is negative half. So sine is negative in the third and fourth. But as per principal value branch, it can only be in the fourth quadrant. So we have to take it as, what is that angle whose sine is half? if I ignore negative sign for a moment, it is 30 degree or pi by 6. So it is negative sine pi by 6. And how do you put it in the fourth quadrant? Sine of negative pi by 6. Because sine minus theta is minus sine theta. So in minus sine theta very much lies in the minus pi by 6 lies in the principal value branch. So what is the value of finally sine inverse negative half? Sine inverse negative half is negative pi by 6, and you know negative pi by 6 lies in the principal value branch, that is negative pi by 2 to pi by 2. Now take the second case, that is cos inverse negative root 3 by 2. Second part, cos inverse negative root 3 by cos inverse negative root 3 by 2. Now what is the principal value branch of cos inverse x? It is cos inverse x lies between 0 to pi. Cos is negative in the second and third. So we can't take it in third, we have to take it in second. That means of the type pi minus alpha. So let it be theta. So what is the value of cos theta? Negative root 3 by 2. What is that angle whose cos is root 3 by 2? 30 degree. So cos theta is negative, you maintain 30 degree or pi by 6. Now in the second quadrant, how do you take it? Pi minus alpha. So cos of minus cos pi by 6 may be written as cos of pi minus pi by 6. Pi minus pi by 6. You know cos 180 minus alpha is minus cos alpha. That is cos phi pi by 6. And of course phi pi by 6 or 150 degree lies in the principal value branch. So finally we may conclude that cos inverse of negative root 3 by 2 is phi pi by 6. And let's see what is the third part. The third part is tan inverse minus 1 by root 2. Take the third part. Tan inverse minus 1 by root 2. Now what is the principal value branch for tan inverse x? It is minus pi by 2 to pi by 2 open interval. Tan theta is negative in second and fourth. So second is not in our principal value branch. We can take only in the fourth, like in case of sine inverse x. So how do you take it? Let it be theta. So tan theta is, if tan inverse of minus 1 by root 2 is theta, so as per definition, tan theta is minus 1 by root 2. Minus you maintain. What is that angle whose tan is in the first quadrant, whose tan is 1 by root 2, 45 degree or pi by 4. So it is minus times tan pi by 4. Or in the fourth quadrant, how do you take it? Tan of minus pi by 4. You know tan of minus theta is minus tan theta. So finally, what do you conclude? That is, the value of tan inverse minus 1 by root 2 is minus pi by 4. So it is minus pi by 4.